Well, here we're asked to rewrite the expression, the cotangent squared of theta minus the tangent squared of theta, and rewrite that in terms of the sine of theta. So we're going to try to get all these terms written into some expression that involves the sine of theta. Well, let's start this way. Let's first think about the cotangent squared of theta. We're going to work our way to left to right. Well, the cotangent squared of theta is the cosine squared of theta over the sine squared of theta. And then we're going to subtract from that the tangent squared of theta, and we're going to rewrite that as of course, a quotient identity as the sine squared of theta over the cosine squared of theta. Well, let's see. We're trying to get everything written in terms of the sine of theta. Well, if I think about the cosine squared of theta, right here at the where we got the definition, well, here and here in our definitions of the cotangent squared and tangent squared of both of theta, the cosine squared of theta, using the Pythagorean identity, is equal to 1 minus the sine squared of theta, and of course this is still over the sine squared of theta, minus the sine squared of theta, and we use the Pythagorean identity again on this cosine squared of theta as 1 minus the sine squared of theta. Well, we're getting close there. We got everything written now in terms of something in terms of sine, but we've got two different denominators here. So we got to get to a common denominator, and we can simplify this thing. So let's see, we're going to take this left part, 1 minus the sine squared of theta over the sine squared of theta, and we're going to multiply it by 1 minus the sine squared of theta over 1 minus the sine squared of theta, and that's going to be times 1 minus the sine squared of theta over the sine of theta. And then on the right hand side of this, where we've got the sine squared of theta over 1 minus the sine squared of theta, we're going to multiply it by the sine squared of theta over the sine squared of theta. And this should give us a common denominator. Now, if I'm working across the top on the left-hand side where I got 1 minus the sine squared of theta times 1 minus the sine squared of theta, numerator times numerator, denominator times the denominator. Oh, that's a squared. I got to get my squared in there. Let's see. In the numerator, then we're going to have 1 minus 2 sine squared of theta plus the sine raised to the 4th power of theta over, and we're going to distribute now here to the bottom, 1 minus the sine squared of theta times sine squared of theta. That's going to be the sine squared of theta minus sine theta to the 4th power. And then over here on the right-hand side, we're going to have the sine to the 4th of theta over sine squared of theta minus sine of theta to the 4th power. Well, now we can combine, let's see, I'm going to give us a little bit more room over here to the right. Now we can combine these as 1 minus 2 sine squared of theta plus the sine of theta raised to the fourth power minus the sine of theta raised to the fourth power all over sine squared of theta minus the sine of theta raised to the fourth power. All right, we can combine a little bit of the like terms where my positive sine to the fourth of theta minus the sine to the fourth of theta, those are going to cancel out. And we're going to be left with 1 minus 2 sine squared of theta over sine squared of theta minus the sine of theta raised to the fourth power. And that's our answer, ladies and gentlemen. Right there. Woo, let's see. Okay, well, first thing we did, we used the quotient identity, and then we used some Pythagorean identity, and we got ourselves to a common denominator. Had to do a lot of distribution, but we have done what they asked us to do. We rewrote the cotangent squared of theta minus the tangent squared of theta just in terms of the sine of theta using trigonometric identities. Whew. Shazam.